Hello, and welcome to this first discussion on Chapter 8 material. This chapter is all about bonding and how atoms are bonded together. So in previous chapters, we've looked at the electron states in an atom. We've looked at the electron configuration, and we've looked at the electron diagrams. And now we're going to actually talk about how atoms come together and form bonds. Both in ionic bonds, covalent bonds, and metallic bonds. So this metallic bonding is the type of bonding that occurs in like a gold nugget or a steel sword. It's the actual force that holds those atoms together, those different types of metal atoms in the case of the steel sword, or it could be all the same element type, but the atoms together. And the way that occurs is you imagine um, nuclei that are close together with all of these electrons surrounding each atom. Now the electrons are able to jump from atom to atom and essentially move in a very interchangeable kind of fashion. And this electron cloud is essentially shared for all atoms. So all of the atoms in a particular hunk of metal will share a sea of electrons from all of that are resulted from just this sharing. So the electrons are interchangeable between the different atoms themselves. And so that's what we mean when it refers to metal nuclei floating in a sea of electrons. All of these nuclei, which are positively charged, are all being balanced. The positive charge are being balanced by the sea of electrons. And this is why metals can conduct electricity. It's also partially why they conduct heat so well. It's because these electrons can actually transfer, and electricity is just the movement of electrons through materials. So when we get to the next set, the ionic compounds we've already discussed, and we gave it the basic definition of a bond between a metal and a nonmetal. But in reality, ionic compounds are made up of electrostatic attractions between ions, which means each of the atoms, quote unquote, in the bond, they have to be charged. And so we looked at sodium chloride, Na plus, Cl minus. So each of these species are charged, and since has a positive charge, this has a negative charge, there's a very strong pull between the two, and we call that an ionic bond. Now some things like ammonium chloride, NH4Cl, ammonium chloride, this has got a +1 charge, this has got a -1 charge when they're not combined. When we see this has no metals in it, but we still consider this an ionic bond. This is an ionic bond because we have a cation and an anion coming together to form one compound. This actually requires transfer of electrons between the two atoms or ion types. And so in this case, sodium is donating an electron to chlorine. All of a sudden, chlorine has a -1 charge. The sodium species has a +1 charge. We get an ionic bond. Finally, we have covalent bonding, which is the sharing of electrons between atoms. Now, this sharing is done in order to often achieve what we call the noble gas configuration, or to give what is called an octet to those particular atoms. And we'll discuss that in a later video.